We start by depicting the given information on the Cartesian plane. Let P be any point on the given curve described in the problem statement. The tangent to this curve at the point P cuts the x-axis at the point T. The distance between the origin and the point P is equal to root of x square plus y square, where x, y are the coordinates of point P. Let's assume that the tangent PT makes an angle psi with the positive direction of the x-axis, and therefore angle PTO is equal to pi minus psi. Now we drop a perpendicular from the point P onto the x-axis. Let's assume that the foot of the perpendicular is n. Therefore the distance Pn is equal to the ordinate of point P, which is y. Now in right angle triangle, PNT sine of pi minus psi is equal to the perpendicular y divided by the hypotenuse PT. And therefore, PT is equal to y upon sine of psi, which is equal to y times cosec psi, which can be written as y times square root of 1 plus cot square psi. Now tan psi is equal to the slope of the tangent PT, which is also equal to dy upon dx. Therefore, PT is equal to y times square root of 1 plus dx upon dy whole square. Now we are given that OP is equal to PT, which implies that square root of x square plus y square is equal to y times square root of 1 plus dx upon dy whole square. Taking the square of both sides, we get x square plus y square is equal to y square times, in brackets, 1 plus dx upon dy whole square. Y square cancels across the left hand side and the right hand side, and therefore we get x square upon y square is equal to dx upon dy whole square, which implies that dx upon dy is equal to plus minus x upon y. Separating the variables, we get dx upon x is equal to plus minus dy upon y. Taking the integral of both sides and adding the constant of integration, say ln c, on the right hand side, we get ln x minus ln c is equal to plus minus ln y. Using properties of logarithms, the right hand side can be written as ln of y raised to the power plus minus 1, and the left hand side is equal to ln of x upon c. This implies that x upon c is equal to y raised to the power plus minus 1, and therefore x upon c is either equal to y or 1 upon y. Now in the first case, when x upon c is equal to y, we get x is equal to cy, and in the second case, when x upon c is equal to 1 upon y, we get xy is equal to c. Now x is equal to cy is a line that passes through the origin, and P is a point on it. Clearly in this case, OP is always equal to PT. Since this is a trivial case, it is ruled out, and therefore the only solution is xy is equal to c.